All right, we've got this great problem here, simple string characters. In this kata, you'll be given a string and your task will be to return a list of ints. That's abbreviation for integers, meaning whole numbers, detailing the count of uppercase letters, lowercase numbers, and special characters as follows. In this example, and they've named the function solve, we've got a string. The string has, I don't know, maybe that's roughly 12 characters or so, a little more. So this is a special character, special character, special character. That's 3 special characters, followed by 4 capital characters, followed by 5 lowercase characters, followed by 5 numbers. And the order is uppercase, so we saw 4 uppercase, yep. Lowercase, we saw 5 lowercase. Numbers, we saw 5 numbers. And then special characters, and we saw 3 special characters. I said 12, it's actually 17 characters. More examples are given in the test cases down here, and good luck. All right, great. So in this problem, I'm given a string. I'm meant to return an array. That array will have 4 integers, or whole numbers. Whole numbers just means numbers that don't have a decimal. And each of those represent a count, first of uppercase letters, then of lowercase letters, then of numbers, then of special characters. In our example here, they're given in sort of groups, but I think we can't assume that they're going to be given in those same groups when we solve the problem. Let's take a look at the tests first. I always go to the tests after I read the problem and glean some more information. Open this up here. So the first thing we're going to do is just comment out or even delete all of these extra tests. They might be helpful to us, but we can write our own tests as we go. They start off with a very simple case, the simplest we should consider, which is an empty string. And when we're given an empty string, we should return an array of 4 zeros. Let's go ahead and pass that. Now right away, I'll run my tests and see that I'm failing. Good. Let's write some code that will pass this. We can just go ahead and return an array, 0, 0, 0, 0. And now we should be passing this simple test right here. Let's go ahead and run that. Hey, yep, we see that we're passing our first test. Now, I'm going to diverge from their tests here because they've already got a case with mixed cases. I'm going to go in order, and I'm going to start with some capital letters. We'll say A and D and Z, for example. With these 3 letters, we should get a count of 3, and the rest of these should all have a count of 0. I might even write out a better messages here. Let's describe this as a function that gets the count of all uppercase letters, lowercase letters, numbers, and special characters. There we go. A little typo here. And then here we'll describe our first case, which is it handles an empty array. And we did that. With that, let's pull out all of this. And I'm just going to drop it down here where we can refer to it if we want. Now there's only one case that makes sense here. I'm sorry, it handles an empty string. Yep, that's good. And here we'll say it handles the count of uppercase letters. Okay, we'll put in our callback here, and then we will just take one of these. Looks good, and make sure we close that out. Very good. All right, and with that, let's run our test again. Well, I made a mistake in my test syntax. Got too many parentheses right there. Try that again. All right, so we see we're still passing our case with an empty string. However, we're failing our case with some uppercase letters. No surprise there, since we haven't written any code for that. So let's get started. Now, if we know that they're only uppercase, we could say something like const uppercase letters equals s dot length. And then we can take uppercase letters and put it here. Let's change this to uppercase count. I think that reads a little bit better. And then we'll put that in here. So if our whole string is only made of uppercase letters, then we could say s.length are those uppercase letters. And if I run that, we see that, yep, we're passing just like that. I'm going to leave it like that, and I'll make this a bit more sensitive when I add a new case for lowercase letters. So let's go ahead and bring in a new statement, and we'll say it handles the count of lowercase letters. Let's see, I've got a typo here and here. And we'll still use A, D, Z, but now they're all lowercase, and I've moved my 3 into that second position. And let's go ahead and run our test. And of course we're failing. We're failing now on this one of handling lowercase letters. Well, I can't simply say uppercase is s.length and lowercase is something else. So let's write a loop here. Let's say for let I equals 0, I is less than s.length, I plus plus. And then we'll say const current character is equal to s at I. Now we'll need to say if uppercase, do one thing, else do another thing. Well, we need to then think, how do we know if something is uppercase? I'm going to say if current character is equal to current character dot to uppercase. That would be one way to write a test if it's uppercase. If that is true, then we want to increase the uppercase count. So here I might say let uppercase count. Now I'm going to change this to 0. And then if I find an uppercase letter, I will say uppercase count plus equals 1. Else, again, we're working in a world where we're only dealing with uppercase and lowercase currently. So here I could say lowercase count plus equals 1. Now I haven't defined this variable yet, so let's go up here and do that. And we're going to say let, oops, did I make a mistake there? Yep, I just copied let, unfortunately. There we go, equals 0. And now lowercase count needs to show up where this 0 was. This is looking pretty good. So we've got our uppercase count and our lowercase count. Eventually those will be put into this array here. Here's a little typo there. And there. All right, got that fixed up. Our loop is going to say for every letter in S, we find that current character, we check if that current character is equal to itself moved to uppercase. In case this isn't clear, if I have A, and I say is A equal to A dot to uppercase, and of course we should put quotes here to show that these are strings. First we resolve this. A to uppercase is still just A. There we go. And A is equal to A, therefore it's true. If I did the same thing with a lowercase a, then this to uppercase is equal to an uppercase A, and these are not the same. Therefore, it's going to come down to this case here. So that's what this check is doing. Let's clean up, and let's go ahead and run our tests and see if we're passing. Okay, I've got a problem. Current character is not defined. Oh, that's because I called it current char. I think we're good there. Run that one more time. All right, now we're passing all of those. Let's go ahead and add a couple more tests into each one of these. So I'm going to say here, what about if I had just zebra? That would be 5 uppercase letters. And we'll add one more test here. And what if I had Popeye? That would be 6 lowercase letters. I think we should still be passing just fine, but we'll give that a test. Yep, good. Okay, let's get rid of this. And let's move on to a new test, and this will be numbers. So it handles the count of numbers. Let me just clean up a little bit, keep ourselves nice and tidy here. this is out of place too. There we go. All right. So if I had numbers like 436, that would be 3 numbers, and 10,572 would give us 5 numbers. So let's go ahead and run that again. Okay, no surprise there. We failed on handles the count of numbers, and that's just because we didn't do that yet. All right, so first thing is when we have, if a current character is equal to itself to uppercase count plus equals 1, if I were to send a number into this and I say 2, is that equal to 2.2 uppercase? Well, a number to uppercase is just going to be the number. So this actually will return true. That is not what we want because that will count our numbers as uppercase letters. So let's go ahead and put in a condition before this that says if, we'll write a comment here, if current character is number. We've got to figure out how we can represent that in some code here. I could do something like if current char is equal to 0 or current char is equal to 1, ... because we of course have to do that 10 times. It will certainly work, but that's going to take a lot of code. Let's see if we can find something else that might work. We could write ourselves a little string called digits. And here we could do something like 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then we can say if digits.includes current char, then the number count goes up by 1. Now, of course, we need to add a variable here called number count. Set that to 0. If you're not familiar with this, we've got a string, and we've just put all of our digits into this string. And we've used this method includes. Includes is an array method or a string method. And it says if this string includes this character, then we're going to change number count. Now, because we don't want to double up here, we're going to do else if this, and then we'll move on to our lowercase letters. This is a pretty simple way to check for numbers, and it should work for us. Let's go ahead and run it. Uh-oh, something's not quite right. Oh, we forgot to. Don't let me drag you down. I forgot to put number count here. Let's go ahead and run that. All right, and now we're passing all of those. We've got one case left, which are special characters. So let's write some tests and work on those. So again, I will just copy this out, and I'm going to say it handles the count of special characters. Now, these are going to be any characters that are not letters or numbers. So if we said like @ exclamation mark, %, £, that would give us 4 special characters and nothing else. And here I might say we have parentheses and @ I think that should work fine. And that would give us a count of 0, 0, 0, 3. Okay. Now, like usual, we run our tests. We expect that to fail. Yep, we see we have 5 green tests passing and 4 green tests, and our 5th test is red, and we don't have the right count for our special characters. So, our special characters will definitely fall under the same case as our uppercase letters, because again, if I take a special character like this and I put it .to uppercase, well, then I have a problem because this to uppercase is just this. So this will return true for our special characters. That means we're going to have to handle it up here. We're going to say, well, it's not going to be included in the digits, so that's fine. Well, how can we do this? One option is we could rework how we're checking for capital letters and then possibly for lowercase letters. so that our special characters just sort of fall to the bottom of our filter. We could do the same thing we did with numbers, and we could say const special characters is equal to a string where we put in all the special characters. But the downside here, of course, is that we're going to have to create a string that includes all special characters, which is going to be pretty tedious to make sure that we've got them all, and then we're likely to introduce bugs if we miss any. So I don't love that approach either. We could say if we could get some logic that says if the character is not a number and not a letter, well, then it would be a special character. So the question is, how can we introduce this logic in code? Let's go ahead and write up something to stub this in. So I'm going to say something like, if the character is not a number and not a letter, then we'll do special char count plus equals 1, just like we did the rest. And of course, for this, we're going to also need a variable, let special char count equals 0. And before I forget, we'll put that down in our array here, replacing this 0. Very good. I'm going to get rid of this comment here. Okay, but we still then have to figure out, well, how would I know if a character is not a number and not a letter? I can think of two approaches here. One is we could use a regular expression, which is maybe slightly more than, I would just say maybe slightly beyond very beginner approach to this. Another option is we could look at the character code, which you may or may not know about. We have to investigate that a little bit. These are the two methods that come to mind, or that not methods, but rather the two approaches that come to mind. I think we'll just go over char codes and we'll use that, and we'll use regular expressions another time. So we'll digress here just a minute, talk about character codes, and then we'll come back and write some logic. Every character on our keyboard, or not on our keyboard, really, any character, has a corresponding number. A lowercase a, for example, corresponds with the number 97, and lowercase b corresponds with a number 98, and so on and so forth. And same with the numbers. They would also correspond with some other character code. So do special characters. I don't know off the top of my head what the code is, but maybe it's 45 or something like that. I happen to know these two off the top of my head. I don't know this one. What if we said something like, if the current character dot char code at, I believe that's the method to get our char code, is not in the range of the lowercase or the uppercase letters, then we can count it as a special character. Let's go look at char code chart and see if we can find a quick reference for this. Here's talking about our method char code at that I just wrote down. All right, so here we can see, I made a mistake. I said A is 97, capital A is 97, lowercase a is 65. You know what, this doesn't, no, I didn't make a mistake. See, uppercase A, oh, but this, okay, this doesn't seem like exactly where I want to be. Let's just look for a quick image here. This is a one I usually use. Okay, uppercase A, 65. Lowercase a, 97, right here. Lowercase a, 97. So even these numbers, 0 through 9, have a char code, 48, 49, etc. So we just need to look at the ranges of these numbers, and anything that's out of these ranges is going to be a special character. Let's start with our numbers. We need things that are less than 48 and greater than 57. So let me come back here, and I'm going to say, if the current character's char code is less than 47, and it is greater than, what was it, 50, 0, 48, 9, 57. Yep. Less than 47 or greater than 57. Did I get that right? Just want to be really careful then. No, nope, I didn't. Less than 48. Now, this is going to get pretty cumbersome, and it's going to make regular expressions look pretty good, because we also need to say and. Let me start breaking this down. And here, and we'll do that. Yep, okay. Now we're going to do the exact same pattern here for letters. We're going to say less than 65, greater than 86. I'll have to check that for sure. And then one more time, less than 97, greater than 123. We're going to check all of these. So 65 should be a 65A, yep. Less than 65, greater than 90. Looks like I made a big mistake there. Greater than 86, greater than 90. And then we'll check our lowercase letters, less than 97, greater than 122. I think I'm off by 1 there too. Yep. All right, so if our current character is less than 48 and greater than 57, and less than 65 and greater than 90, and less than 97 and greater than 122, then it's a special character. Let's go ahead and pull this out, which is our character code. Let's go ahead and say const character code is equal to this, and then anywhere we have this, we're going to replace that with our character code. That shortens it down a little bit. Not the most graceful way to find special characters, I will warrant you. Let's run it. All right, I made a mistake. Something is wrong here. What is our problem? If this special character count 1, but we're somehow counting a lot of our special characters. Char code at, let's go ahead and console log our char code. 64, 33, 37, 51 is the @ sign at 64. 64 @ sign. Yes, what did I miss up here? 65. If char code is less than 48 and greater than 57, yes. These should be ORs. Nope. Nope, nope, nope. Now I've just made a mess of this here. This is better, but one of these, let me just check to make sure my numbers are correct. So in this case here, oh, no, actually that's fine. I just put a 3 in there. I'm not sure why. I think I meant to do that. We'll test that again. There we go. Now we've got it working correctly. And let's clean up. And we'll talk about this. All right. So up at the top, we've created 4 variables. Each of them will keep track of the count of the uppercase, lowercase, numbers, and special characters. we've written a loop here to go through every character. We're denoting the current character with this variable current char. We've got let's go ahead and set this actually up here outside of the loop, and string to represent all of our digits. There we go. The character code we'll keep down here. It's fine. And then we're going to go through each one. We're going to check if it's not in the range of numbers or uppercase letters or lowercase letters, then it's a special character. Otherwise, if it's included in digits, then it's a number. Otherwise, if it's equal to itself when it's put to uppercase, it's an uppercase letter. Otherwise, it's a lowercase letter. And then we return our array with this count of all of them. And that looks good. Let's write a couple more tests, and now we're just going to write some with mixed cases. So it handles the count of all characters. So here what I want to do is actually I'm going to pull out some of this data that they had provided for us earlier. We'll just drop these right in here. You know what? Let's take all of these and drop them in here. Then we will uncomment them, clean out this here. Great. And we should be passing all of those. If we've handled everything, yep, looks good. Handles the count of all characters. I think we've done pretty good here, at least passing everything. Let's go ahead and attempt it. Yep, and we see we're passing. Very good. Now, I'm not supremely happy with this code. Let's see if we can make a few changes before we submit it. The first thing I'm thinking is, if we're going to go with character codes, maybe we can just be consistent and test that all along the way. So what if, instead of this sort of convoluted logic up top, we were to take out this here, and we're going to say if the character code is greater than 47 and less than 58, that would be a number. Let's go ahead and pull this like that. Otherwise, here are our uppercase letters. So we can say if the character code is greater or equal to 65 or less than or equal to 90, I think that was a bug there actually, since it said greater than, then it's uppercase. Else if, here we'll pull out this one, the character code is less than or equal to 97 or greater than, oh I see, it wasn't a bug. We want to say less than or equal to. Here, let me grab this one more time, put it in here. If the character code is less than or equal to 48 and greater than or equal to is greater than or equal to 48 and less than or equal to 47, greater than or equal to 65, and less than or equal to 90, greater than or equal to 97, and less than or equal to 122, else it's a special character. Put that there. Hopefully we can simplify a few things here. We can get rid of digits now, since we're not using that at all. All right, so, and we don't, we could keep this, but I think we can just as well here say s at I, which is our current character. Let's see if I've mangled that too badly. Got an extra parenthesis here and an extra set here. Try that again. Well, it looks pretty bad. I've got my uppercase letters counting wrong. Our uppercase letters are here, greater than or equal to 65, or less than or equal to 90. Let me check my chart here. Capital A is at 65. Yeah, that looks good. If the character code is greater than or equal to 65, or less than or equal to 90, uppercase count plus equals 1. But my uppercase letters are going into my numbers spot, it looks like. If the character is, aha, because all of these need to be and now. Tricky, tricky. Try our test again. Yep, there we go. Okay, so that simplified this a little bit. Definitely a good practice in understanding how character codes work. Let's go one more approach that will be, I think, the most interesting. And for this one, we're going to go ahead and get rid of all of these variables. And we're going to comment out all of this. We might use some pieces of that. And we're going to say something like const letters, or rather characters, because they're not all letters, is equal to s dot split. And that's going to give us an array of characters. Then we're going to say characters dot reduce. Now here we've got our array that we want to count into, and our current character. We'll call this current character. We're going to move into a function here. We start out with an array that is 0, 0, 0, 0, oops, like so. And we're going to say if current character. Now, here we might grab on to some of this. We're going to, you know what, let's get our char code. So we'll say const char code is equal to current character dot char code at. Excuse me. Then we'll grab this block here. Good. Now, we want to say something like array at, this is the number count, so array at 2 plus equals 1. And then this will be array at 0 plus equals 1. Array at 1 plus equals 1. And for our special characters, array at 3 plus equals 1, return array. We're going to drop this line completely. And here we could really return from here, but we probably want to give that a variable. Let's go ahead and try it like that. We'll run our tests again. We've got such a nice test library, we can easily change our code and make sure it still works. Great, I'm going to start deleting old code. See where we're at here. Okay, let's run our tests again, make sure everything's working fine. All right, so in this approach, we tell reduce to start with this array of 4 zeros. We go through every current character, we find the character code, and then we use our logic here to say if the character code falls in this first range, then it's a, we could say here, it's a number, otherwise it's uppercase letter, otherwise it's lowercase letter, otherwise it's a special character. let's take this, put it there, put that there, put that there, move it in, something like that. Run that. Yep, okay. You know, it's a little bit shorter, but I find it pretty hard to read. I don't love it. Fancy use of reduce, but still just not the most readable. All right, well, we're going to end on this one for now. Let's go see what other people came up with. I'm sure we'll see some great ideas. Okay, so here's the idea of using a regular expression. I don't love these variable names, too short. Uppercase, digit, no. Uppercase, lowercase, not sure why D there. Number, special character. And they could have used const with all of these and then return their array. Yep, looks really good. Definitely regular expression shine here. Again, bunch of regular expressions doing a really good job. This is using reduce. I'm not sure why they needed to wrap this, because they made it an object. This seems, I think they could have just done this with reduce and an array. Here's kind of where we started with to lowercase to uppercase, and then checking for digits, and finally special characters. Looks good. Here's kind of what I did, where and then they wrote everything out, which seems like overkill. Yeah, we want to be with something like a regular expression. And none of these look so great. All right, well, maybe we'll come back and do this one another day with regular expression. Like this. Nice and clean. Yeah, that's fine too. Interesting. Here, it's an interesting problem. You've seen a lot of variation in the solutions. All right, well, we'll end there. Hope that was helpful. Thanks so much.